Hello everyone, I'm Gabriella Damasceno and today I show you part of the result from my PhD. This study is entitled Per-capita impacts of an invasive grasses vary across levels of ecological organization in a tropical savanna. So, for a general context, invasive grasses are a huge problem for the conservation of tropical savannas outside Africa, mainly in South American and Australian savannas. And among the invasive species, we have Andropogon gaianus, Melinis minutiflora, and Urucloa species. And the impacts of these species, as all invasive species in general, are related to the abundance of the invasive species. And one way of understanding that is about constructing abundance impact curves. And in this figure, abundance is in the x-axis and the impact or effect of the invasive species is in the y-axis. So you can have constant per capita impact of the invasive species, and that means that every new individual added to the area has the same impact on the system, and usually that delivers a total linear impact of the population of the invasive species. But you can also have varying per capita impact. And in this case, the total impact caused on the system cannot be linear. The impact could be positive or negative and increases and decreases. And this is really important for considering management plans because the abundance impact curves differ depending on the impact being measured. So an species could have a linear impact, total linear impact, considering one asset of the invaded area, but could have non-linear impacts at others. And in the aim of this study, we trying to understand how the abundance of the invasive grass is associated with its impact on the invaded tropical savanna. And we hypothesized that the impacts would be non-linear. The relationships between the abundance of the invasive and the impacts would be non-linear because the state and transition dynamics of tropical savannas. The sampling was conducted in Cerrado, the neotropical savanna located in South America in Brazil. We studied two natural preserves of Cerrado, one in Estação Ecológica de Tirapina and the other one in Parque Nacional de Brasília. The samplings were conducted at the end of the rainy season in 2019 in March and April. And for the study, we delimited abundance gradients based on the ground cover of the invasive species Urucloa brisanta, and we established 60 plots measuring 5 by 5 meters, and every plot corresponds to a level of abundance by the invasive species. And 5 of these plots, going from 0 to 100% of cover by the invader, are called a gradient. And in every gradient, in every plot, we sampled variables related to the microhabitat, the individual, the community, and the ecosystem level. So the results. At the microhabitat level, we found a non-linear impact of the invasive species on the cover by bare soil. And it was a positive effect at initial levels of invasion, but a negative effect after around 40% of cover by the invader. But we found always negative impacts considering the other microhabitat characteristics sampled, like daily luminance and daily temperature. And these patterns probably result from the reduction in cover of the native species during the early stages of invasion. So the bare soil amount increases, but the amount of invasive tussocs are not enough to cover this soil that it's exposed. What happens after 40% of cover by the invader when the tussocs of the invasive species starts to merge? And this results in effects of temperature fluctuations because the temperatures are buffered. At the individual level, we didn't find an effect of the invasive species abundance on its own specific leaf area values, neither on the SLA of native dominant species, but we found a positive linear effect of invader abundance on the total SLA values of the community because the invader replaces native species, causing biotic homogenization and leading the SLA values towards its own values. At the level of ecosystem, we found an effect of invader abundance on its total biomass, but it was non-linear and decreases at the higher levels of invasion, probably because of increased interspecific competition and also environmental constraints. And we found a negative effect on native biomass, but a total impact positive in the total amount of biomass because the replacement of the native species by the invader. But we didn't found effects of invaders abundance on the decomposition rates and CO2 soil efflux. And this indicates stability of carbon cycles due to the functional redundancy between the invader and native dominant species, and also agrees with the smaller effects of invasive species at higher levels of ecological organization. And putting together all these results indicates an indirect effect of the invader in nutrient cycling because it increases productive at initial levels of invasion by increasing the amount of biomass, but at totally invaded areas it could cause nutrient immobilization because the decomposition rates does not follow the same pattern. Now, considering community, we found effect on shrubs that was similar to the pattern found for bare soil cover, and this indicates that the shrubs might be benefited at initial levels of invasion because the exclusion of native grasses, but after some point around 40% of cover, they are also excluded by the invasive species. And relating to graminoids and forbs, we found nonlinear decreasing effects of the invasive that are increased at around 25% of invasion. And it's caused by the impact of invader in excluding native species due to shading and competition. Considering the impacts on the cover by dead biomass of native species, we found a nonlinear decrease caused by the invasive species due to the merging of its two socks. Considering the richness of species, we found the negative linear impacts of the invader on species richness of both graminoids and forbs, but a non-linear decrease in species richness when all species were considered together. And this indicates that richness could be not the best indicator to evaluate the impact of these invasive species because where graminoid and farm species could be already lost at initial levels of invasion. So, concluding, we found greater impacts of the invader on community levels and some impacts at the ecosystem, but not at individual levels. And the non-linearity of impacts on community indicates that management at early stages is essential for conservation biodiversity of these ecosystems. Thank you. I'll be happy in receiving some questions.